So in the last session we discussed about force and extension. Now we'll do some questions related to force and extension. MCQs. I want everyone to participate so that it shows your understanding. Don't bother about the wrong answer because you will learn from your mistake and it will improve your understanding. In the first question, the diagram one shows a beam balance, a beaker with a wire loop. So a beaker is there which is having a wire loop, balances with the standard masses. The beaker is then removed and hung from a spring, and the spring extended 5 centimeter as shown in diagram 2. The experiment is repeated with the same apparatus on moon. Keep in mind the value of the gravity on the moon is smaller compared to that of Earth. Where the acceleration of a free fall or the value of the gravity is less than Earth, which statement describe what happened on the moon? So what could be the right option? A, B, C or D? A beam is balanced and the spring extended by 5 centimeter. The beam remained balanced and the spring extended less than 5 centimeter. The right hand balance span is higher, or right hand balance span is higher and spring extended less than 5. So what could be the right answer? Yeah, that's good, Abdullah. B is the right answer. Why B is the right answer? Because the mass of an object does not change. Even we take the same balance on the moon, it will balance because amount of matter does not change. So it will remain balanced. But what about the gravitational pull? Because the spring is stretched by the weight of this beaker and the loop. As we take this beaker to the surface of the moon, the value of the gravity or the weight is smaller. So if smaller weight is there, the extension of the spring will be less than 5 centimeter. So B is the right answer. Is it clear, this question? To everyone? So basically it is showing a concept that mass does not change and the weight of an object changes. That's why it will have different extension. In question 2, an experiment is carried out to measure the extension of a rubber band. Extension means increase in length. The results are shown. When load is 0 means we did not attach anything. The length of the rubber is 15.2 and it does not have any extension. When we add 1 Newton, like we attach 1 Newton, the new length is 16.2. So what is the extension? Extension means increase in length from original. So originally it is 15.2, now it is 16.2. So the extension is 1. Which figure is missing from the table? What should be the number here? When we attach 2 Newton, it has the extension of 2.1. So what is the total length? Length of a rubber band, here it is mentioned, experiment is carried out to measure the extension of a rubber band. So we have a rubber band. Originally this rubber band is having a length of 15.2. When we add a load of 1 Newton, so when we add a load of 1 Newton, the total length is now 16.2. So how much is the extension? The extension is 1. But now the question is, if we attach a 2 Newton, the extension or increase in length is 2.1. So what is the total length? So if originally it is 15.2 and extension or increase in length is 2.1, so what will be the total length? It will be 17.3. So B will be the right answer. Is it clear? This question? A student add a weight to an elastic cord. Elastic cord means it can change its shape, size, and return back to the same original length. He measured the length of the cord for each weight. He then plot a graph for the result. On x-axis, he is having a weight. What should be plotted on the vertical axis? So on a vertical axis, we should have extension. If weight is on x-axis, extension on y-axis. If weight is on y-axis, extension on x-axis. How we can calculate the extension? So example, if nothing is attached to the cord, that length is known as original length. When we attach a load, so when we attach a load with this cord, that is known as the measured length. So how I can get the extension? How to know how much it is extended? So how we get the extension? If measured length minus the original length, what we get? We will get the extension. So that's why D will be the right answer. So when we plot a graph for Hooke's law, we normally plot for force and extension, load and extension. So basically, indirectly, they're asking how extension is calculated. So extension is calculated by subtracting the measured length or subtracting the original length from the measured length. Is it clear? This is question 3. In the question, they're asking what should be there on y-axis? What label should be there on y-axis? If you remember, we discussed the Hooke's law. So what we take, if we take load or force here on x-axis, the other axis should be extension. Because in a Hooke's law, the graph is plotted between the load and or the force and extension. So they're asking what has to be plotted on the vertical axis, like what value should be there on vertical axis. So on the vertical axis, if load is on x-axis, vertical axis must be extension. And how extension is calculated? It is calculated by subtracting the original length from the measured length. The spring is suspended from a stand and a load are added and extensions are measured. Which graph shows the result of plotting an extension and load? Which graph is correct for load and extension? A, B, C or D? When load is 0, extension should be 0, because if we did not attach anything, the extension will not increase. So if you have a spring, example, original length is 5 centimeter. Now what you did, you add a load 1 Newton and it is 7 centimeter. So extension is 2 centimeter. If I add another load, example 2 Newton, the extension will be 9 centimeter, the new length will be 9 centimeter, and extension will be 4 centimeter. So you can clearly see, so when we increase the load, the extension will also increase. So D will be the right answer. Initially no load is added, but later we are adding a load, and what will be the graph for load and extension? Is it clear? Question 4. So according to Hooke's law, force and extension are directly proportional. Increase in force will increase the extension. Question 5. A spring is stretched by hanging a piece of metal from it. What is the name given to the force that stretches the spring? A, B, C, or D? Mass is not the force. Mass is there, but mass is not the force. They're asking for the force. So the definition for the force, that is weight. So weight is the force that causes stretching, and spring will change its length. Question 6. A student carries out an experiment to plot extension and load graph. What is the extension caused by the load? How we calculate the extension? Original length is x and measured length is y. How to get the extension? So the measured length minus the original length, that's right. Y minus x will give us the extension. An object with the different masses are hung to a 10 centimeter spring. The extension of a spring is directly proportional to the mass hung. What is the mass of M? If 100 gram, a force or a mass of 100 gram, a mass of 100 gram, how much extension is caused? That is 10. What will be this mass which caused how much extension? Originally it is 10 centimeter and finally it is 30. So the extension is 20. We simply use the ratio. If 10 gram is causing 100 gram is causing 10 centimeter extension, so this mass M will cause 20 centimeter extension. Cross multiply. When we solve this, it will be 100 multiplied by 20 divided by 10. So it will be 200 gram. So C will be the right answer. Is it clear, this question? Simply directly proportional ratio. Quantities are there. If you increase one, the other will also increase. The next question, the extension and load graph is there. The unloaded length of the spring is 15 centimeter. When object of unknown weight is hung, the length of the spring is 16.4. What is the weight of the object? So we have to use a graph. First, what is the extension? Originally it is 15 and now it is 16.4. So what is the extension? Extension will be 16.4 minus 15. That will be 1.4 centimeter is the extension. Now we have to use the graph to find the weight, because on y axis we have extension. Each box is representing 1. So this is 1.1, 1.2, 1.3 and 1.4. So this is 1.4 extension. So when the extension is 1.4, we want to find the weight. So using a graph, when we draw a line, when the extension is 1.4, the weight is this value, so which is between 3.1, 2, 3, 4, and this is 3.5. So C will be the right answer. Is it clear, this question? First, using the change in the length, we got the extension, and from extension, we calculated the weight of the object. Then tomorrow we'll do some structure questions. The first one I will solve now, and later we'll do the remaining. What is Hooke's law? State Hooke's law. Hooke's law state force is directly proportional to extension under elastic limit or within limits of proportionality. Then the second part, part B, a force up to 120 Newton, spring obey the Hooke's law. So when the force is 120, extension is 64. So when the force is 120, each box is representing 5. So this is 110 and this is 120. The extension is 64. So each box is representing 2. So 62 and 64. So when the force is 120, extension is 64. And when it is obeying a Hooke's law, it should be a straight line. So what we'll have a straight line for this graph. Till force, as they mentioned, when the force is 120, the extension is 64. Is it clear? Then calculate the second part, calculate the spring constant. How we calculate the spring constant? Or K, we have the formula F is equals to KE. So K is equals to F divided by E. So force is 120 and spring constant is 64. So it will be 120 divided by 64. That will come out as 1.9 Newton per millimeter. A student make a spring balance using a spring that maximum reading on the balance is 150 Newton. The spring constant shows the difficulty to stretch the spring, that is force divided by extension. How much force is needed to produce 1 millimeter or 1 centimeter extension? That is known as the spring constant. A student make a spring balance with a maximum reading on the balance is 150. The student tested his balance for the weight of 140 and the balance. He observed that the reading are not 140. Explain why the reading are not 140. Like what they mean here, student make a spring balance. Spring balance means a balance which is having a spring. So he used a spring balance and his spring balance can maximum read 150. But when he attach a load of 150 or 140, as I mentioned in the question, so when he attach a load of 140 to the spring balance, he found that it is not showing correctly. The pointer, like here is 140, here 150. So the reading is not correct. It is not on 140, it is on another value. When he attach a load of 140, it is not balancing or at level at 140, it is at another level. So what could be a reason why the spring balance is not reading 140 accurately? So what might be a reason? the spring might crosses the elastic limit, deform permanently, so spring might deform plastically. What does it mean might deform plastically? It means like the length of the spring, when the spring does not cannot return back to the same original length when the load is removed, or there is a deformation in the spring. That's why it, when we attach a load of 140, it should show 140, but it is not showing 140, it is showing another value. Is it clear? Part C, like there's a deformation in the spring, that's why it is not showing the same number, it is showing another number. So these are the questions related to Hooke's law. The next session we'll start do some questions related to Hooke's law and start a new topic which is about force and acceleration. Any question related to the class today? So I'll end the session and share this.